Alright, so we talked about how a derivative represents the slope of a tangent line. So in this video we are going to take a look at how to graph a derivative if we're given an f of x graph. So keep in mind that f prime represents the graph of the slopes. So sometimes, we say slopes of tangent lines, but we can abbreviate that by just saying that f prime is going to represent a graph of the slopes. Okay, and it's the slopes of f. So take a moment and sketch the graph here that we have for f of x, and I've identified 6 key points which we've labeled A, B, C, D, E, and F. And so what we want to do here is we want to take a look at this f of x graph, and then we want to produce a graph for the derivative. Now notice how I have my x and my y labeled, and then over here I have an x and a y prime. It's a good way of thinking about the derivative graph. Instead of just labeling y up here, we're going to label y prime because it is a graph of the slopes. So let's go back and take a look at the points here that we see along the graph of f of x. And let's get a feel for what the slopes would be at each point. And again, when I say slopes, I mean the slopes of the tangent line. So let's focus at point A here. If we were to draw in a tangent line here at point A, let's suppose we had information that told us that that slope is 4. Notice how it's fairly steep. Okay, it's definitely a positive slope. So let's suppose we have a slope of 4 there. Now A is right on the y-axis where x is 0. So I'm going to go over here to my derivative graph, and when x is 0, we know the slope is 4. So I'm going to plot a point right here at 4. So this really is my point A, and I'm going to call this A prime. Okay, so it's the new point on the derivative. Okay, take a look at point B. Alright, this slope is not as severe. Okay, it's beginning to level out a little bit. Let's suppose that slope is positive 1. And let's say that our point B is somewhere between 1 and 2. So somewhere between 1 and 2 for the x value, the slope appears to be 1. So over here, somewhere between 1 and 2, I'm going to plot a slope of 1, and I'm going to mark this as B prime. Let's go back over to our f graph and look at our point C. Right at the top there, it appears that C is a maximum. It's a high point, and at that high point we know the slope is going to be 0 since the tangent line is perfectly horizontal. So point C, let's say that happens at the x value of 2. Okay, that's going to be right here. I'm going to mark off C prime. That point is the point 2 comma 0. So again, when x is 2, the slope is 0. So what I'm tracking here is what the slopes are at each of these points. So take a look at my point D. If we were to draw our tangent line slope in here, let's suppose that tangent line is a slope of negative 1. And let's say the x value at point D is 3. So when x is 3, my slope is negative 1. So now I'm down below the x-axis here. Okay, so 3, negative 1 is what I would plot. Let's suppose that at point E, our slope in this situation, let's say it's not quite as steep. Let's say that that is maybe negative 0.5. Okay, so, and let's say that at point E here we're talking about an x value of 5. So count over to 5, and say that in this case we have our E prime. The slope we're saying is about negative 0.5. Okay, and lastly at F, we can see that's a low point, so that means our slope is going to be 0. Let's suppose that happens at the x value of 6. So at 6, we're back up here to 0. So you're not going to be expected to label points like this. Generally speaking, you're just going to be expected to produce a graph. Yeah, you want to start by marking off key points like we did, but what you have to do in the end is just draw your function. So this would look something like that, and it would continue to go up. Okay, so this would be a graph of our derivative given the graph of f. So the key is to track your slopes, get a feel for what's happening. So if we were to just kind of go back and generalize here a little bit, notice how the first portion of the graph, it's rising, it's increasing. If the function is increasing, we know we're going to have positive slopes. So it appears to increase all the way to point C. So notice how over here, all the way to point C, this is above the x-axis. So that indicates that the slope is positive. Then notice how between point C and point F, notice how our function is decreasing, right? It's going down from left to right. Well, notice over here between C and F, it is below the x-axis. So when your derivative graph is below the x-axis, that indicates that your function was decreasing. And then after f, we can see that the function begins to increase again. So if the function is increasing, the slopes are positive, and if the slopes are positive on my slope graph, also known as my derivative graph, it would have to be above the x-axis, because that means we would have a positive slope. And then of course right here at these points on the x-axis, that's where our slope is 0. That's happening where we have a minimum or a maximum.